Please make sure you have this Section 6.1 notes sheet out in front of you. This entire Chapter 6 is going to deal with systems of linear equations, so I think it would be a good idea to know what we're dealing with. So let's take care of these vocabulary words. If you need to pause the video or rewind it, please feel free to do that at any time. System of linear equations is our first vocabulary word, and a system of linear equations is two or more linear equations containing two or more variables. In this class, we are only going to focus on two equations with two variables. And in most cases, we're going to be solving for an x and a y. We're going to be interested in what the solution of a system of linear equations is. And so a solution is an ordered pair. And remember, an ordered pair is a coordinate point. It has an x and a y value. So an ordered pair that makes each equation a true statement. So an ordered pair that makes each equation a true statement. So that is what our solution is. And that's what we're going to be interested in finding. Now we have a big idea associated with solutions of an equation. Back in the last semester, you've been solving a lot of equations and getting an answer. It's called a solution. And if you would substitute that solution back into your original equation, you would get a true statement. And so that's kind of what our big idea is. If an ordered pair if an ordered pair is a solution, it will make both equations true. So if an ordered pair is a solution, it will make both equations true. So let's try to use that to figure out whether or not some of these ordered pairs that are going to be given, if these are solutions. So let's take a look at problems numbers 1 and 2. In numbers 1 and 2, I notice that I have a system of equations, and I notice that I have an ordered pair, and I want to know if the ordered pair is a solution. So if it's a solution, it's going to make each equation a true statement. Remember, our first coordinate's x, and our second coordinate is y. So what I'm going to do is I'm going to substitute in x and y into my equation, see if I get a true statement. So if I plug it into the top equation, I would have 2 times 1 plus 3, and I want to know if that's equal to 5. And 2 times 1 is 2, 2 plus 3 is 5, so I'm going to say that's true. I'm going to plug 1, 3 into the bottom equation. So I have to answer the question, is negative 2 times 1 plus 3 equal to 1? And negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. So it ends up working in both equations. And since it works in both equations, then I can answer number 1 as yes. The ordered pair 1, 3 is a solution. So let's take a look at number 2. Let's do the same thing here. I have 2, negative 1. So 2 is my x value, negative 1 is my y value. Let's plug those into each equation, see if I get a true statement. It has to work in both. So let's plug it into the top one first. So I'm going to have 2 minus 2 times negative 1. And I want to know, is that equal to 4? We have to be careful with the signs here. If I take negative 2 times negative 1, that gives me positive 2. So this is really 2 plus 2 equals 4, which is true. Let's plug it into the bottom equation. I'm going to have 3 times 2 plus a negative 1, and I want to know, is that equal to 6? Well, 3 times 2 is 6, and then plus a negative 1 is 5, so I would end up getting 5 equals 6, and that's false. So since I found one of them that it doesn't work, that means the whole answer for this is no. So it has to work in both of them in order for it to be a solution. We're going to figure out how to find solutions a few different ways. We're going to do it graphically, and we're going to do it using the substitution method, and we're going to do it using the elimination method. Let's first solve by graphing. And so that would be our example down here at the bottom. Solve this system of equations by graphing. All right, let's go ahead and do this. If I take a look at my first equation, y equals negative x plus 3, I know that in this equation, my slope is the number that comes before the x, negative 1 over 1. My y-intercept is that coordinate at the end, 0, 3. So let us first start at 0, 3. That means I'm going to start at 0, 0, and I'm going to go up 3 spots. There's 0, 3. My slope is negative 1 over 1. So the negative 1 on top is going to tell me to go down because it's negative. The one on the bottom is going to tell me to go to the right. So I'm going to go down 1 and right 1. And then I'm going to go down 1 and right 1. Down 1 and right 1. And you can keep going down 1 and right 1 as much as you want. I'm going to try to get as many points as possible. I could also go up 1 and left 1. And once you get all that taken care of, then let's try to draw on the best line that we can. And now we need to graph the other equation. And so if I graph this other equation, I notice that in the second equation, my slope is the number that comes before the x, which is a 1. And then I have a plus 1 at the end, so that tells me I'm going to start at the coordinate 0, 1. The one on top tells me to go up because it's positive. The one on the bottom tells me to go to the right because it's positive. So I'm going to start at the point 0, 1, which is right here. My slope is up 1 and right 1, and I can keep going up 1 and right 1 as much as I want. I probably don't need to go up 1 and right 1 too many more times because I already see where they cross. So I'm going to get just a few more points on here just to have a decent looking graph, and then try to draw on the best line that you can for this one. Now, the point that I am interested in is this point right here where they intersect. This is my answer. And so I'm going to write my answer as an ordered pair. So my answer is going to be the ordered pair 1, 2. And so that would be the solution to my system of equations. And if I substituted 1 in for x and 2 in for y into both of those equations, both equations would end up being true statements. All right, on example number 4, let's do exactly the same thing that I just did on example number 3. The first thing that I'm going to do is I'm going to write down what my slope is. So in my first equation, my slope is the number that comes before the x, negative 2 over 1. And then that plus 4 is my y-intercept. That tells me that I'm going to start at the point 0, 4. The negative 2 at the top, since it's a negative, tells me that I'm going to go down. And the 1 on the bottom tells me I'm going to go to the right. So let's start at my coordinate 0, 4. There's 0, 4. My slope is negative 2. That means I go down 2, right 1. And you keep going down 2 and right 1 as much as you want. Down 2, right 1. I can also go up 2 and left 1. And then try to draw on the best line that you can. Now let's graph the second line. My second line, the slope for my second line, slope is the number that comes before the x, and it's a 1. So my slope is 1 over 1. Negative 2 is my y-intercept. I'm going to write it as a coordinate. It would be the ordered pair 0, negative 2. So I'm going to start at the point 0, negative 2. My slope is 1. So the 1 on top tells me to go up. The 1 on the bottom tells me to go to the right. So go up 1 and right 1 as many times as you can. We're really interested in where these two graphs intersect, and I think I've already found that point. So try to draw on the best graph that you can here. Now, what I'm really interested in is where these two intersect. And the two lines intersect right here. So that's my answer. So my answer is an ordered pair, just like we wrote at the front of the sheet for the vocabulary. The answer is an ordered pair. And that ordered pair would be the coordinate 2, 0. Now, in this last problem, we got one line that's just a little bit different than everything else. So let's graph the one that we're probably familiar with, which would be the bottom one. So in my bottom line, I know that the slope is the number that comes before the x, 1/3. And then I see a negative 3 at the end. So that tells me it's the coordinate 0, negative 3. My slope of 1/3, the 1 on top, tells me to go up because it's positive. The 3 on the bottom tells me to go to the right because it's positive. So I'm going to plot the point 0, negative 3 right here. My slope is 1/3. Go up 1, right 3. Up 1, right 3. I can also go down 1, left 3. Down 1, left 3. And then draw on the best line that you can. Now, the other line that might be a little bit trickier is this one at the top. It says x equals negative 3. Remember, we can always make an xy table for everything. Graphing using slope-intercept form is just more efficient. But I'm going to make an xy table for this. And I'm told that x is always negative 3. So let's let x be negative 3. I could really pick anything I want to for y. I might as well pick things that are easy to plot. And I think numbers like 0, 1, and 2 are easy to plot. You could, again, pick anything you want, but those are easy to plot. So I'm going to plot the point negative 3, 0. Right there. Negative 3, 1. And negative 3, 2. I think I have a pretty good idea of how this line is going to look. It's a vertical line. And I am interested in where these two graphs intersect. And they intersect down there in the lower left-hand corner. That's in the third quadrant. I need to write my answer as an ordered pair. And the coordinate of that point is negative 3, negative 4. And that would be my solution to my system of equations.